Welcome to this explainer. Today, we're totally reframing everything we thought we knew about how brains learn. If you've ever felt like the traditional classroom was built for one very specific type of mind while leaving everyone else behind, well, you're definitely not alone. We're going to unpack some cutting-edge neuroscience that looks at neurological differences not as broken machinery that needs fixing, but as incredible, unique profiles of human cognition. Okay, let's dive straight into this. We're going to start with the neurodiversity paradigm shift, then explore 3 unique neurological profiles. After that, we'll look at the hidden cost of masking and wrap up with how we can actually affirm neurodivergent identities. Part 1, the neurodiversity paradigm shift. It is time to officially ditch those old, rigid learning style models, the ones like VA-ARC that strictly labeled you a visual or auditory learner. The science has moved way beyond that. We're looking at a staggering statistic here. 15% of the population. That is roughly 1 in 7 people who are neurodivergent. We're not talking about some rare medical anomaly. This is a massive natural variation of the human population. Millions of brains just naturally process information differently than the statistical norm, which is exactly why those old, rigid models just completely fall apart. And this brilliantly illustrates the big shift we're making. For decades, the system relied on a deficit model. It treated neurodivergence like a broken machine, something dysfunctional that you had to fix or remediate to make a student learn the normal way. But now, we're moving to a neurodiversity affirming model. This framework recognizes these neurological differences as natural variations. Sure, they come with distinct challenges, but they also bring incredible strengths. The goal isn't to fix the brain anymore, it's to remove the barriers and actually leverage those natural strengths. Part 2, 3 unique neurological profiles. We're going to take a fast-paced, balanced look at the real neurobiology behind ADHD, autism, and dyslexia without all those old deficit labels. Let's start with ADHD. Historically, this was just brushed off as hyperactivity, right? But neuroscience shows it's fundamentally about how the brain handles motivation, arousal regulation, and executive function. It is heavily tied to differences in dopamine reward pathways and temporal difference learning, which is basically how your brain predicts future rewards. So, to put it simply, this is exactly why a student might agonizingly struggle to focus on a dry, boring worksheet for even 5 minutes, but then turn around and play a fast-paced, highly rewarding video game for 4 hours straight in a state of absolute flow. Now, what's really interesting about this is how the traditional challenges of ADHD perfectly mirror its greatest strengths. The exact same dopamine dysregulation that causes a learner to completely check out in a rigid, passive classroom, that's the very same engine that fuels massive hyperfocus, rapid ideation, and divergent thinking when they're in a dynamic, creative, interest-based environment. The trait isn't the problem at all. The environment's mismatch to the trait is the problem. Next up, autism spectrum disorder. The research frames this around the weak coherence account. I know, it sounds a bit dense, but it basically means having a cognitive style that sees the highly detailed trees in absolute high definition rather than just zooming out to see the general forest. It's not a cognitive deficit, it's a highly specialized cognitive style that excels at local processing and incredible pattern recognition, alongside differences in social communication and sensory processing. And the contrast here is just stark. Think about a noisy, traditional classroom with visually cluttered walls. For an autistic learner, that creates immense sensory overload and anxiety. Throw in all those confusing, unspoken social rules, and it is just exhausting. But if you place that same learner in a structured environment where their sensory needs are actually met, you unlock this extraordinary neurological capacity for deep expertise, highly logical reasoning, and complex systemizing. Our third profile is dyslexia. Often, people mistakenly think it's just reading backwards. But actually, dyslexia involves distinct neurological differences in phonological processing, literally how the brain connects sounds to symbols. Crucially, research shows that these language processing struggles often coexist right alongside incredible visual spatial capabilities. It's a unique trade-off. This is why so many famous architects, engineers, and storytellers are dyslexic. Their brains are beautifully wired for spatial design. The problem is, traditional education heavily emphasizes reading speed and spelling. That unfairly penalizes dyslexic students. It basically grades them solely on their neurological challenges while completely missing their natural talents. These learners naturally excel at visualizing, spatial relationships, innovative design, big picture reasoning, and holistic problem solving. If we're only evaluating them with timed written tests, we are entirely missing their brilliance. Part 3. The high cost of masking. Now, we need to shift gears to a more serious note because we have to talk about the real villain in this explainer, the systemic pressure to just fit in. Ask yourself this: what is the true cost of acting normal? When we place neurodivergent students into environments that pathologize their natural traits, they don't just stop learning, they suffer. To survive the bullying, the social rejection, and those rigid expectations, many individuals engage in masking or camouflaging who they really are. This tragic reality is captured perfectly by a 2026 quote from Grant and colleagues. "Masking is life, but it suppresses learning while protecting from harm. It's a heartbreaking trade-off." Students are literally hiding their true selves just to survive the school day. The research even highlights something called double masking for neurodivergent working-class students who feel forced to suppress both their class identity and their neurological identity at the same time. This intense, constant performative act causes massive anxiety, depression, and severe identity confusion. And here is the heavy science behind why this is so damaging. The DMN misdirection hypothesis. Your brain's default mode network, the DMN, is normally responsible for playful exploration, creativity, and healthy self-reflection. But when a student is forced to mask due to identity threat, that network literally gets hijacked. Imagine the anxiety of trying to remember a complex password while someone is standing right over your shoulder watching every keystroke. That intense, anxious self-surveillance is exactly what's happening in the masking brain. Instead of freely exploring ideas, the brain redirects all its energy into panicking. Am I passing as neurotypical? Will they see who I really am? Creativity is completely suppressed by fear. Part 4. Affirming neurodivergent identities. Let's move to our final section and see how this all builds toward a better path forward. So how do we move from the exhaustion of masking to creating spaces where all brains can actually thrive? The gold standard here is Universal Design for Learning, or UDL. Basically, UDL means designing accessibility into the environment from the very beginning. It's exactly like architectural curb cuts on a sidewalk. They were originally designed for wheelchairs, but they end up helping people with strollers, bicycles, and delivery carts too. UDL does that for learning. You provide multiple ways for students to take in information, express what they know, and engage their interests. It helps everyone right from the start, rather than awkwardly retrofitting accommodations for struggling students later on. So, the crucial point is this. If we want to restore healthy DMN brain function and improve mental health, we have to change the environment, not the student. We need to remove that identity threat so the brain can finally stop its anxious self-surveillance. Provide sensory accommodations like quiet spaces or noise-canceling headphones. Encourage authentic expression, whether that means letting an ADHD student stand up and pace while working or letting an autistic student dive deep into a special interest. We have to value their authentic selves. I want to leave you with this final provocative thought to take back to your own schools, universities, or workplaces. What if the problem isn't, and literally never was, the learner's brain, but simply the rigidity of the room they were put in? When we finally stop forcing diverse minds to conform to a single, narrow standard, we don't just reduce anxiety, we unlock incredible systemic potential. Thanks so much for joining me for this explainer, and I really hope this sparks some exciting changes in how you view the minds around you.